Well, we have one more award now. This is another exciting award. This is the Innovation Award. This was first proposed by the Standards Oversight Committee in recognition that our standards really only recognize adherence to a minimum level of performance. But there are many, in fact, probably most aquaculture members of the value chain that are working on innovations, and we should recognize those. So beginning a few years ago, we offered an award, and we asked nominees to send in their ideas, and we have a panel of judges from the Standards Oversight Committee that judge these. And this award is sponsored by a company that I think is one of the most innovative in our business. And so I'd like to play a little video clip of Preferred Freezer. Actually, John Gallagher, the CEO, is at this cold storage, I believe, right now. Here you see automated pallet unloading. When trucks enter this robotic plant, there's no person that's there to receive the material. It automatically unloads. And this is during startup and testing. Normally this would be totally dark and robotic picking. This facility, I believe, has 450,000 square feet and can handle well over 100,000 pallets. And everything's totally automated and highly efficient. And here you see loading rail cars. It's one of the parts that is done still by forklift. So amazing innovation. It's an area that one might think there's no more need for innovation. What's a cold store? But no, the refrigeration systems, the efficiency, the freezer burn, the data collection, the management of the inventory, and all the food safety aspects are all very important. So thank you to Preferred Freezer, and once again, John isn't here with us to present the award, so let me go ahead. First, let me mention we had some finalists. The fifth award winner, the fifth group in the list, number 5, was a group called AgriProtein, which produced an insect meal, basically digesting organic waste and making an insect meal. The fourth one was Ohio Soybean Group that developed soy with very low anti-nutritional compounds, removing a lot of the carbohydrates, a great improvement in the use of soy. The third group was one called TransAlgae, and they have developed modified algae that can deliver vaccines, that can deliver growth promoters to aquaculture species through the algae. Another great innovation. The number 2 actually was a Canadian group called Catalyst, and they developed technology for recycling water using duckweed. Basically, the duckweed plant absorbs the nutrients. The duckweed then can be fed back through the diets. A great innovation. So always difficult to make a call, but the winner is a group called Camanor out of Brazil, and I'd like to invite Werner Jost to come to the stage. Camanor came up with an innovation that I think can revolutionize the shrimp farming business. They've studied how to raise shrimp in a totally closed environment, pond environment, but control all the variables and produce high yields very efficiently. All this may sound normal to you, but the remarkable part is to reuse the water over and over again, 4 or 5 cycles in a row on the same water. Very high yielding, very efficient, very stable. Well, what does that say about eliminating disease? Low footprint, the ability to put this kind of system anywhere. It's just a remarkable innovation. I know you're going to want to hear more about it. And I also want to mention that Werner was one of the very first founding members of GAA, maybe back in the late 1990s. So a Swiss gentleman, always leading the way on sustainability and social rights, way ahead of his time. And so let's welcome Werner Jost.
Good morning to you all. Thanks very much, George and Wally and the judges of the panel for the confidence they had in my project. So it's always very nice to gain an award, but I think for me it's something much more important. It's like maybe the end of a journey which lasted about 33 years. A journey to search for a new way how we could do aquaculture. So maybe I have to explain. I'm an economist by formation, so when I started to do aquaculture or shrimp production in Brazil in '83, I always was puzzled how little we knew about what was happening in the ponds and how difficult it was to control a pond. So in the last 30 years, we learned a lot how things happen, but we learned as well that in the end, low density, big ponds can't be controlled. So getting this award from such a prestigious organization as GAA, for me is like a proof that we made it, that we got to a solution how we can produce shrimps in a different way. So for me, that's very important. Thanks you very much. So I would like to bring to you a little bit what is aquascience about. So we start with a short film that gives you an idea what it is about. So please, could you show it?
Camanor Produtos Marinhos, featuring aquascience, a new concept in sustainable production. Integrating different systems into one, the aquascience system is an excellent alternative for a sustainable production with high productivity in a healthy and extremely stable environment for the animals in production. The aquascience system eliminates the possibility of environmental degradation by recycling nutrients and by the total reuse of water between production cycles, preserving natural resources and generating significant savings of inputs applied to the system, reprocessing waste, zero disposal to the environment, recycling and water reuse. The guiding principle of the aquascience system is environmental stability for interaction with pathogens. Proof of environmental stability can be observed in the graphs comparing the variations in key water quality parameters obtained before and after the introduction of the system. Increasing production capacity with high rates of survival, even in the area affected by diseases such as white spot virus and the IMNV. All this stability is converted into a better performance of production when compared to traditional farming systems. As the results are obtained without the use of harmful substances and without the need for antibiotics, aquascience makes a revolutionary system that enables a truly sustainable production. Camanor, Produtos, Marinhos. Produce results preserving nature.
So before I go to some slides which show more details about our system, I would like to thank my two partners in Brazil. One is Marisa Sonehara. She is with me for the last 20 years, and she gives a lot of stability to our organization. And Luis Enrique Peregrino, he is the mastermind behind AquaScience in the way that all the microprocesses which in the end make up the system, he is inventing and putting up. He's really a very special guy, and without him it would have been impossible to create such a system. So what made us create AquaScience? In 2011, we were hit by white spot, so we lost about 95% of our production, and we were extremely hit by the white spot. So in the end, we closed down the low-density ponds we couldn't produce, and our hope was on some small ponds, line ponds, which we were trying to produce under the Asian production protocols. But to our surprise, we were not successful. We had white spot in the pond all the time. We lost all the production. And so we had 10 cycles of production which we lost all the time during the 2 years. So it was a very difficult time, especially financially. But in each cycle, we learned something new. And we adapted the next cycle always a little bit. So, for example, bringing tilapia in or working with covering the ponds with a shade cloth. So in the end, in the 11th cycle, we succeeded, and we first produced in a new technology which we then called AquaScience. So here you can see a unit. There are 2 ponds of about 4,000 square meters. They are all lined. In between you have like a treatment pond, an integrated treatment pond, and you have 2 smaller ponds which are stocked with high-density tilapia. There is a central drain in all the ponds, and the water is circulating in this unit. So there is no water coming in, and there is no water going out during the cycle. And what is even more amazing is when we harvest, the water goes out through the gate, then we pump it into a reservoir, and after we clean the pond, we pump it back, and the next cycle begins. So now we are already in the 6th cycle without changing water. Here you can see the scheme we have seen in the film, but it was very quick. So we talked about the complete recirculation of the water. Up you have the pond where we have aerators, we have blowers, we work with biofloc, and we have a lot of probiotics. So what is very important in this system is to work with stable parameters. If that's it for oxygen, for pH, or for temperature, because this creates an environment which leaves the animal stress-free, and if it's stress-free, then it can resist to diseases. Because the pathogens are present, at least white spot we have in the pond. So if we lose the control of a parameter like pH, in 3 or 4 days, the pond is dead. So for us, it's extremely important that we can control these parameters. So there is no waste accumulation. You can see in the pond, bottom there is a central drain. It was called yesterday or day before as a toilet. So the waste is going down to the treatment tank in the first phase, which is an anoxic tank, where there is a denitrification, and part of the waste is going to the tilapia tank. The tilapia feeds on it, converts into biomass, and then the water goes back to the pond. Then the rest of the water, which doesn't go to the tilapia tank, goes to the second phase, which is for nitrification and for there's a lot of aeration. So in the end, the water goes back to the tank. So it's a recirculation 24 hours a day. And all the waste is processed. This is really extremely fascinating because in the end of the cycle, we put about 1 ton of feed per hectare per day. And all these waste is in the end recirculated by the bacteria. So when we harvest, the pond is clean, and we are ready for the next cycle. So you have seen this in the film as well. You can see the parameters. The red lines are the old data we had from the low density ponds, and the green lines are the aquascience ponds. So it's very easy to see that the parameters are very much stable than before. Here you can see the evolution of Camanor's productivity. The first cycle was about 10 tons, and within 2 years we could get up to nearly 46 tons in a cycle. I think it's really easy to go over the 50 tons. So if you think we have 3 cycles a year, term 50 tons, we have 150 tons per hectare and cycle. I would like to talk a little bit about high density in animal production. You can see here a picture of chickens, and it's very easy to see that there is very little space left. So I put 90% of the space taken, maybe it's even more, so it's really high density. If you compare this with our system or any system in aquaculture, if I take my example of 300 shrimps in the end of the cycle with 20 grams, that would be about a biomass per cubic meter of 6 kilos. These 6 kilos you can transfer in more or less 6 liters of volume of bodies if you put them all together. If I compare the 6 liters of volumes to the 1,000 liter of my cubic meter of water, you can see that the animal bodies occupy less than 1% of the whole water in the system. So they have 99% of the water just to swim around, to roam, to feel well. So this is something the marketing has to explain, because I think when we talk about high density to the consumers in at least Western Europe or in United States, the reaction is always negative. So I think we have to change how we communicate with the consumers, and we have to explain that one thing is land-based animals in high density, and the other is high density in aquaculture. And as Robin Smith told me today, maybe it's better not to use high density as a word and just to work with high yields. This is much more sympathetic. So if we look at the waste, you can see on the chicken, there is an accumulation of solid waste during the whole production cycle. So this waste is only removed when the cycle is at the end and the animals go out, and they remove the waste and they reprocess it or maybe throw it away, I don't know. But if you compare it to the solid waste which is recycled in aquaculture, and at least in our system of aquascience, so there's a huge difference between one system and the other. We have to explain this to the consumers, so the retailers have an important job to do to say how things really work. And in the end, it's the capacity of water to reprocess waste. So in the air, that is much more difficult. So that's the reason why in the poultry business, you can't reprocess your waste during the cycle. You have to do it afterwards. So what are the further developments? We will make deeper ponds. So if we double the depth of our ponds, then we can double our production per hectare. So instead of talking about 150 tons per hectare a year, we can talk about 300 tons a hectare a year. And if we are trying to get new aeration systems because we want to have a lower impact on electricity consumption. I think this is a part of sustainability as well. Use as less energy as possible. And we would like to work with genetically more advanced post-larvae. Now we have a growth of 1.8 in average per week, but we know that it could be possible to have maybe 3 or 3.5 grams per week. So in the same system, in the same construction, we could have the double of productivity. So what is the outlook for the next 3 years? We will try to bring our production up to 450 tons hectare a year. This is possible, as I said, because we will go to a double of depth. And I think we can have an increase on productivity by using genetically improved larvae. They grow better. So instead of 3 cycles, we can do 5 cycles, or we can do 3 cycles with much bigger shrimp. So our production cost of 20-gram shrimps will be about $2 per kilo, which I think is very competitive if you compare it to other world producers. And what is more interesting, I think we can build 1,000 tons of capacity per year with about $1.5 million, which I think is in the lower end if you compare it to other systems and other countries. So if we presume that maybe world shrimp production is about 4 million tons a year, and if we look at the 450 tons hectare per year, we could in theory imagine that with less than 10,000 hectares of aquascience technology or something similar, we could produce the same amount of shrimp as is produced nowadays in the world. And that's amazing. So you could imagine that in one province, in one country, you could produce as much as you produce nowadays on a worldwide base. And that is amazing or scaring, I don't know, it depends on the point of view. But I'm very cautious about predictions because you never know how the future will go, but I think we are at the threshold of a new era in shrimp production. I think it will be very interesting to see how things will develop over the next years. And Camanor every year creates a campaign for its employee to motivate them for the next year. So I would like to share with you the campaign of 2014. I think it reflects very well how we feel or we felt when we had the first successful production in the aquascience technology. It's a bird, a phoenix rising of his ashes, and the slogan was, "Reborn in a new dimension." So thank you very much for your attention.
Awesome, Can we get a picture? Yes. Maybe a handshake?